So yeah, by the time, hey there everyone, good morning, I'm Anashuman Singh, and I am a GSOC mentee here at FOSSASIA. I was participating last year as a contributor, and yeah, that's something about me. So this session aims to sort of look, it's not just actually setting up Flutter, it aims to look on what Flutter is, how is it different from the native development of of any platform actually, and why is it sort of important for the PSLab and our future goals, right? So let's move forward with this. Yeah, so this is the abstract of the session. What we'll be looking in this session, we have 3 points, 3 major points. The first will be what is Flutter, and we'll have a look at the differences between native Android and Flutter development, because currently the PSLab app is a native Android app, and how will be shifting to Flutter would be advantageous for the app. The next thing would be how we can set up Flutter. Actually, it's very easy, and there are lots of ways to set up Flutter, and how you can build your first app to get started with cross-platform development. And then the last session would be, the last point would be PSLab-oriented point, like how we can sort of, it's like what is PSLab and how is it important for to shift to Flutter, right? So let's just dive into the first point. Yeah. So the first and a very important question: what is Flutter? Why is this hype about Flutter which is going on, right? And what it does is which is different from native development, so that it's very useful. So Flutter is the best thing, like what we're here for, right? Flutter is an open source UI toolkit. Why do I say it's a UI toolkit? Because it's sort of, it's a UI, because it's a graphic engine built on top of the already formed Dart compiler, right? And it's developed by Google, and it's for building natively compiled applications for mobile, web, and desktop from a single code base. So the thing is that you have a single code base, you write the code for both the front end and the backend in Dart, and then you can compile it and you can sort of deploy it on mobile, you can deploy it on web, you can deploy it on Windows, Linux, Mac OS, and whatnot. So yeah, how does that work? So it uses a Dart programming language, and the Dart programming language basically decompiles to native code on each platform, and it also can decompile to JavaScript. So for web, it decompiles to JavaScript. For the other platforms, it compiles to the native code, which is very fast. And it has its own graphics rendering engine, so basically Flutter has 2 graphics rendering engines. One is called the Impeller engine, the other is called the Skia engine. So basically, Skia is something which was a different thing before, and it was acquired by Google in 2005 or 2006, I guess. And then they reused it for the Flutter UI. And the Impeller engine is just, it's built by Google on its own, and they use it for Flutter. And with the latest updates, Skia is actually sort of deprecated. I mean, it's not officially deprecated, but it's sort of deprecated. And Impeller has been deployed on all the platforms which Flutter supports. So let's go forward on something about the Dart programming language. So yeah. The Dart programming language has lots of features, but I have chosen these 4 because these 4 are the features which would sort of impact the most on how you write apps, right? If you're coming from a native background or if you're coming from a JavaScript background. So yeah, the first feature is it sort of offers 2 types of compilations. One is a JIT, or a just-in-time compilation, and the other is a AOT, or the ahead-of-time compilation. So Flutter sort of gives us many what we call as run configurations for our app, for whatever platform we are developing. So we have a debug run configuration, we have a profile run configuration, and then we have the release run configuration. So the debug run configuration uses JIT compilation, which means that you can make changes as you are writing the code. So it means, let's say I have written some code, Flutter code, and I have deployed the app in the debug configuration. I can just quickly sort of make some changes to UI. I can just press enter, and it would hot reload in milliseconds or so, right? So this is one feature which sort of makes it highly convenient for mobile app developers like us, who, when we were writing Android apps, like we always have to sort of make, let's say you have a typo, right? Then the text, and you just sort of delete one letter, and then you have to wait for the next 5 or 10 minutes, if you have a slow PC, to build the whole app from scratch again and to see the changes, right? So this is one thing which improves the development experience by many folds. So in Flutter, you can just kind of make some quick changes in UI, press enter, it hot reloads, and there you have the change, right? The other thing which is as equally as important as just-in-time compilation is the ahead-of-time compilation. Why? Because it converts Dart code into highly optimized native machine code or JavaScript, as I mentioned before as well, to make Flutter apps fast and efficient. So this is one thing, if you use Flutter in the future, or if you have used, you may have noticed that in the debug run configuration, where we make the debug APKs, the size of the APK is huge. So even for a small app, the size could go up to 80 megabytes, right? But when you run it in either the release configuration or in the profile configuration, the size of the app is very small. It's like maybe 15 megabits per second, megabytes. So yeah, that's one thing that shows how highly optimized it is. And that's because the debug mode is made for just-in-time compilation. It's built for that. And it sort of also continuously logs what happens in the Flutter app. Whereas the profile and release configurations do not do that. So profile configuration is used to test the performance of the app, and then the final is the release configuration, which is used for releasing the app, right? The next thing, a unified framework for front-end and back-end. What I mean by this is, if you are coming from a framework like native Android, you may know that we have separate XML files for the layouts, and we have separate Java code for the functionality. So Flutter aims to sort of merge these two. We have widgets, right? Everything is a widget in Flutter, which are written in Dart. And then we control them using other things such as providers, which are also written in Dart. So everything is written in Dart only, right? The third thing, it uses an event-driven single-threaded model. So the main thing to notice here is the word single-threaded, which may interest you a lot. So it means that you cannot create new threads. So if you're coming from Java, you may have, for some complex compilations or computations, you may have used different threads for different computations. In Flutter, you cannot do that. Flutter provides a different sort of workaround for that. It's known as Dart isolates. Those are not actually threads, but those are actually separate isolated memory containers, a sort of thing. So they do not have shared memory. So if you want to do something on a separate thread, you have to actually sort of create a separate memory container for that, right? And what do we mean by event-driven single-thread model? So Dart uses a sort of compilation loop. The event comes in, and then it executes them one by one. So there's concurrency, and there is then single-thread model. And then the last point I've covered provides us isolates for parallel execution. Dart is sort of built on top of JavaScript. I mean, not literally on top of JavaScript, but the sort of how you can say, the sort of syntax is similar to JavaScript. So you can use the async await approach and other things if you want to achieve concurrency. And yeah, so those are the 4 points which are most important and would affect you the most if you sort of move from a different framework. And the rest is just syntax. It's quite easy. Let's move to one of the very important features of this workshop, the differences, right? So in this topic, I'll be explaining what Flutter does different from native compilation, which makes it sort of a phenomenal framework in mobile app development, not only in mobile app development, but for cross-platform development, right? So let's say you have the Dart UI code in the Flutter application, right? So everything is in Dart. There is this layer between the native rendering and the Flutter application, which we call as the Flutter engine. It runs in between, right? The Flutter engine can either be SKA or impeller, as I explained before. So what does this do? The Flutter application would ask the Flutter engine to, let's say, render a sort of UI, what you call as a screen. Let's keep the term simple, right? A screen. What the Flutter engine does, it asks the native layer, because the native layer has the screen of the phone, right? It would ask for a blank screen from the native layer. The native layer would provide a blank screen to the Flutter engine. In Android terms, we call that a surface view. As you can, in simple terms, you can just think of this as a blank screen. The Flutter engine then paints its widgets on the blank screen and then returns to the Flutter application. So let's say if you were standing right here, you would say that the Flutter application is sort of deceiving you, because those are not views which are provided by the native layer, but those are just painted by the Flutter engine, right? But if you see the native rendering layer, the native application would directly sort of communicate with the native layer for the views, and the native layer would return the screen with native views. Native views means views which are present in the SDK of the native platform, right? So let's say in Android, you have an Android button, which has the style, which has the sort of on-click operations, anything you do defined by the Android development SDK, right? The Flutter engine sort of handles everything at this layer, right? So the user clicks on a button. The button is not a button. The button is sort of a painting of a button, right? And so the Flutter engine detects that, okay, the user has clicked on the painting, and then it executes what to do with that. Now let's sort of think of some analogies as to why is this approach phenomenal in Flutter development, right? So I'll take two examples, right? Let's say you want to buy something expensive. Let's say you want to buy a phone, right? You would obviously care if that phone is a genuine phone, a real phone, or a fake phone, right? What is the difference between a real phone and a fake phone? Looks same on the outside, but it's different inside, right? That's one way to look at it. Now let's think of another approach, right? Let's say you buy a pen, right? That pen is sort of an expensive pen, and you use that pen for a long time. The ink of that pen drains out. Now you have two options. You want to buy another pen of the same cost, or maybe you can just purchase a refill for that pen, which may not be the official refill of the pen, which just fits in that pen, and then you can use the pen again. For the latter approach, most people, I think, would prefer purchasing a refill for the pen and then writing using it. But whereas for the former approach, most people, if they are spending that amount of money, you definitely want a genuine phone, right? So what is the thing which differentiates these two cases? It's the cost of the thing, right? Now, if we look at this thing from a broader point of view, these three cases are sort of similar, right? The same thing which I mentioned. Looks same outside, but it's different inside. The same thing is this. Looks same outside, but it's different from inside. Let's see how that is. Now, this is a very ironic slide, right? It mentions the differences. Can you spot differences, right? Just ignore the top bar and stuff like that, and the obvious layout improvements. But the thing is that is a Flutter application which we are working on currently, and this is a native application. How many differences can you spot if you just like remove the obvious things? I mean, you can see there are virtually no differences. We made some layout improvements, but the thing is that it looks same on the outside, but it's different inside. So this right here, which you see, this button, those buttons, the checkboxes, the text, are the real, genuine Android views on the screen, whereas this is just a painting of those views. So that's not a genuine Android button. This is a painting of a button. But whenever we should, so that's the same thing which I mentioned before, right? What is the cost or what is the expense? So for every app which you are building, you have to sort of analyze, is it necessary? Do we actually need those views right there? If we can sort of do the same thing on many platforms, using paintings of views, then why actually do we need the native views, right? If the obvious exception here would be if your app uses something which uses very complex native platform features, let's Android or stuff like that, then you may actually want to have a native application. But with a Flutter application, you get sort of a better development experience, deployment on multiple platforms. So I think this is a very phenomenal thing, and this has been done actually first time in mobile app development. This sort of thing where we abstract the views and the functionality from the native layer and sort of just keep it above. So that's phenomenal in the same sense as is the invention of a refill for a pen, right? You can do amazing things. So that was, I guess we covered that. Yeah. So I'm going to stop here and ask you if you have if you have any questions, you can ask this one before we move on. This was the first sort of thing, first part of the session. If you have any questions, then we can do it, or I'll move for the next part. Perfect. I'll just move for the next part, right? Setting up Flutter. Yeah. So again, this is the same thing. Broadly involves 3 steps, irrespective of your OS. Setting up Flutter is, like, according to me, like of all the things which I tried, this is the easiest thing. Right? You have to configure a text editor or an IDE, whatever you think is best for you. You have to sort of download the Flutter SDK. You have to update a path variable according to the SDK. You have to type of Flutter, and it's done, right? So I remember when I got started, when I got started for Flutter, the thing which you have to do is you just have to clone the Flutter repository. That's it. Git clone Flutter repository, and then you have to sort of update your path variable according to that, and then you're ready to go, right? So, but now that was at that time, but now Flutter has sort of started to ship binaries. So I'll just cover how we can do this for one OS, Linux, right? But in any case, the detailed instructions are available right here on this link, and this is a very nice link. Flutter, like, you can sort of select what OS are you on for development, what is your target OS, and then you can download Flutter that way. So let's just quickly see how we can set up Flutter on Linux, right? So Flutter supports that's the supported OS. Debian, Linux 11, or Ubuntu 20.04 LTS. So yeah, there are some obvious development tools which you may already have if you develop things. So these are that. You can sort of quickly run apt-get update, and then you can install the following packages. If you want to develop Android, if you want to deploy apps on Android and test them, then you would need sort of okay, so that's one question, that why do we need Android Studio if you're working on Flutter, right? I mean, you can work on any IDE. So why is Android Studio required? Because Android Studio sort of gets you all the packages necessary for developing on Android. So let's say if you wanted to develop for Android without using Android Studio, you have to manually search each of the packages, and then you have to install them one by one, right? So if you install Android Studio, it does the same for you it's the same thing as a package manager, right? So let's say you want to install a package, and the package manager quickly install all the dependencies for you as well. So that's a quick way. If you want to develop Android apps, right? Deploy apps on Android. Next thing is Flutter. So you can configure a text editor or IDE. These are some options, and then you have to sort of download the installation binary or bundle from the latest stable release. If you want to use a latest stable release from the website, that's a link, and then you can just sort of you can extract it, and then you can sort of add the Flutter to your path, and then Flutter provides a command called Flutter Doctor to check if everything's fine, right? So this is the sort of way if you want to do it the way Flutter tells you on their website. But if you want to for the latest stable release, obviously, but if you are sort of more of a hacking person, you want to sort of run different versions of Flutter, you want to sort of check, if you want to develop Flutter, then the best thing is still just clone the Flutter repository, check out the branch which you want to work on. Let's say Flutter has tags like 3.27, 3.29, or maybe alpha, beta, stable, main, whatever branch you want to work on. Check out the channel, add the Flutter to your Flutter variable to your path, and you're good to go. That's not much of a work, right? So yeah, that's one thing. Let's talk something about that, right? So Flutter is currently in active development, right? So Flutter recently rolled from 3.27 minor version to 3.29 minor version. And the thing is that the Flutter development team is doing quite of some breaking changes as well in each major release. So how are sort of apps handling it? So what we do is we fix the Flutter version, right? So let's say I developed an app and I fix the version 3.27. There's a way to do that in Flutter, right? There's a way to do that in Flutter. So I fix the version to 3.27. Now, you as a developer, you want to contribute into my app, you have the latest version of Flutter, right? You have 3.29. And you want to develop the app. So the nice thing is that Flutter is always backwards compatible. I mean, you can always build an app which was built using 3.27 with 3.29. However, that app may behave very differently on 3.29. I'll give an example, right? So then we have the obvious, that's why we have the obvious works on my system problem, right? So some person may come and say, okay, this works on my system, but why is it not working on yours, right? How can we solve this? There's a quite standard answer. Anyone would like to guess? We use that in Python, right? A lot of the times. Virtual environments. so yeah, but we cannot do that using Flutter, right? So in Python, we use that approach quite a lot of time. We create virtual environments when we can have different versions of dependencies in one environment, and they can separate it in another one, right? how do we do that for, the best thing to do that in usual development is using dev containers, right? So anyone, I guess everyone would know here about dev containers, or you know? I'll just go through them. What are dev containers? Dev containers are basically Docker containers, and you can sort of, it's a container, it's separated from everything, it's separated from your PC. You can sort of install Flutter in that container, whatever version you want, and you can sort of develop in that. So for one of our projects, which is called the Badge Magic project, we already have a dev container in place, and the dev container runs a cron job, which runs every sort of 7 days or something, and it updates to the latest Flutter version, which we support. And leading IDEs, such as, leading code editors such as Visual Studio Code, they have plugin support for dev containers. So if we have a dev container in a repository, which is nothing but a .dev container folder, when you open that project in Visual Studio Code, it will, and if you, it will just show you a pop-up there, right? With this dev container detected in this project. Would you like to open it? You click on open. It would check if there is Docker on your PC. If not, it would do all the things automatically. And then you sort of open that project in dev container. So I use these a lot to test with the right version of Flutter before I push to the main repository, right? So that is something about dev containers. And yeah, building your first Flutter application. Now, since we have everything set up, you may want to build your Flutter application, the first Flutter application. And that is sort of a huge, huge turmoil. I mean, there are lots and lots of resources available on the web. I was myself in that state, but I sort of picked 2 for you. If you want to do that, there's a Code Lab, Google Code Lab, right, which allows you to build your first Flutter application. And that also teaches you on how you can build layouts which would look good and which would scale effectively on all platforms you develop. So you can sort of deploy that app on a mobile phone or on a PC. And yeah, that teaches you the basic, the best practices. And the next is sort of a YouTube playlist. This is an official Flutter playlist. It also covers the above Code Lab, right? It teaches you some fundamentals about Dart as well. It's not much, it's like 5 or 6 videos if you are into watching YouTube for learning, right? If only. So you can follow that as well. It covers the above Code Lab as well and sort of gets you started building with Flutter, right? So yeah, now we would like to move into the last sort of abstract point for this session, which is the Pocket Sense Lab app. And what is the Pocket Sense Lab app? The Pocket Sense Lab app aims to create mobile and desktop applications which can be used to perform measurements, right? So we have an oscilloscope, we have a multimeter, a wave generator, logic analyzer, power source, and many more instruments into a single board. And I would like to show you that board. This is that board. If you have not seen it before, this is the Pocket Sense Lab board. And so we create desktop and mobile applications to interface with that board. So we have a UI in place, and we can sort of connect to this board using a USB cable and Wi-Fi also, and sort of make measurements and do cool things. So since I have basically less time, I'll just move on quickly, right? So now, why are we talking about the PSLab in a Flutter session, right? So we are shifting the PSLab app to Flutter. And why are we doing so? Because we want to deploy, so basically we have the desktop app for this as well, but it does not work. And we want to sort of have a single code base for whatever platforms we support, right? And not to forget, we want to also deploy the for iOS users to the App Store, right? And so that's the cost, right? So we analyzed that it would be a really nice approach to shift to Flutter if we want to have these things in place. And shifting to Flutter has only been possible due to development of wireless connectivity, because iOS and I guess maybe Mac OS does not allow you to sort of communicate over USB. So if you see there, currently the thing is that the PSLab board communicates with a USB to any device, PSLab Python on a desktop or the Android app. And yeah, so we worked on that a few months ago, and we developed wireless connectivity for the PSLab. And now it can sort of communicate over Wi-Fi as well, and Flutter has its own support for WebSockets. So shifting to Flutter will be advantageous in that ways. And do we have, yeah, those are the repository links. And that brings us to the end of the session. Thank you very much. Any questions? I'm open for that.
Any questions from the audience?
I'm sorry, sorry, I'm not fluent in English. You have the communication between native and Flutter layer. It's like the method channel or something else.
Yeah. So basically, what the Dart developers did is that they sort of built some common functionality, which is there in all the supported platforms, but there's not all functionality implemented in the core Dart libraries. So let's say you want to access some of the functionality which is very native to the platform. Let's take an example, right? Let's take an example of intents in Android. So Dart does not have a sort of a thing which is similar to intents, right? So what you can do is you can sort of develop a method channel which would sort of act as a bridge between the native layer and the Flutter layer. So that allows us to utilize the full functionality of any platform if you're using that. And yeah, so we can sort of develop platform-specific apps also using Flutter. Why is that? Because once you have gone to Flutter, there's no way coming back, right? So you will like it. I personally, that's my personal opinion. You will like it so much that you would not like to go back to the native development stuff like that. So yeah, that's one of the reasons, because Dart supports anything. So you can, if you want to have something which is native, you can do that in Dart using method channels. Dart also has another thing which is called the foreign function interface, or the Dart FFI, which means you can also sort of run functions which are written in other languages in Dart. So let's say you have a C function or something like that, or maybe a Python function, you can use the Dart foreign function interface to run that as well. So that's a cool thing, right? Anyone else?
Cool. We have few more minutes. We can have one more question from the audience. Okay.
Have you tested the performance between native implementation and the Flutter?
Yeah. So as I mentioned, we have to obviously analyze the cost, right? If PSLab is something which relies on performance, right? And the nice thing is that Flutter actually provides very close to native performance, right? It's not native always would perform better, right? But Flutter would perform very close to native, and that's one thing which eliminates other frameworks, other JS-based frameworks such as React Native, right? So, I mean, those frameworks, they render native views, but they use bridges to render native views, which decreases the performance a lot. So that's why I was saying that Flutter is phenomenal, right? Because this approach has been done for the first time in mobile app development, and it provides native, really close performance to native app development with multi-platform support.
Cool. Thank you very much.
Thank you.